Hi, everyone, and thank you so much for coming. I hope your lunch was delicious, and I hope you enjoyed the keynote this morning. So welcome back. This is Containers on AWS with Fargate and EKS. And I have a guest coming up in just a few minutes. So we'll be joined by Roberto Migli from Thales, who's going to be talking about their journey to Kubernetes. So without further ado, a little bit of intro. So who here has worked with containers in production before? So it's not everybody, right? So we're going to start with a bit of intro. So a container is an atomic, self-contained package of software that includes everything it needs to run. So that's code, that's runtime, that's libraries, that's everything. A really popular and widely used platform for this is Docker. So there's a link in there if you want to learn more in your own time. We've been hearing, I think, a lot more each and every day about how people are using containers in production. And I think that brings up a next question, right, which is, why are containers so popular? So they're really portable. They're really lightweight. They only have just what they need. They're standardized. I can take that same container and deploy it anywhere. So from my local environment to a staging environment to a production environment, they're fairly easy to deploy. Just Docker build, Docker run. And along with containers, we have the whole monolith to microservices story. So they go hand in hand. And to introduce that story, so what are microservices? So this is my favorite definition. It's by a guy named Adrian Cockcroft, who now works at AWS. And the semi-funny joke used to be that this was the best AWS evangelist that didn't work at AWS. And he works here now. So if it was ever a funny joke, like all of my jokes, it's no longer funny. And Adrian says that microservices are a service-oriented architecture composed of loosely coupled elements that have bounded context. So what does that mean? Service-oriented, they have a job. Loosely coupled, so I don't have to move one service in order to deploy the second one. And they have bounded context. So if I have a service that's only in charge of UI, once that UI service starts to handle maybe a messaging job, I break it up into multiple services. So why do containers and microservices go together? So one job, one container. So one service, one container. You can deploy and scale them independently. That means with a monolith, if I wanted to scale up just that one function that handles my messaging service, I had to scale up the whole monolith. So my one monolith needed a whole other server to handle it. With services, I can scale them independently. So if my messaging service gets a lot of traffic, but my internal admin dashboard service does not, I can scale those as two separate pieces. Which brings us to the next part, right? Which is that managing one container is easy-ish, and managing many containers is much harder. Which brings us to orchestration tools. So orchestration tools are what help us deploy and manage and scale all of these containers, so we don't need to do all the heavy lifting ourselves. So here's a couple examples. A lot of them might look familiar to you. So the honeycomb logo is ECS, Kubernetes, Docker Swarm, Mesos, all examples of orchestration tools. And there's a couple options just on AWS for container orchestration. So I have ECS, I have the Fargate logo, I have the EKS logo with Kubernetes. Today, we're going to focus on just Fargate and EKS, and then we're going to hear from Roberto on their move to Kubernetes. So AWS Fargate. So I think you all remember this, because it was just a couple seconds ago. So running our one container is easy-ish, and running our many containers is hard. So ECS makes that easier. So it handles some of that scheduling and orchestration. There's a cluster manager. There's a placement engine. Integration with other AWS services, so things like batch and auto-scaling, skills to support clusters of any size you want to run. You get service integrations like ALB and NLB. But it's not totally hands-off. You still have to do some managing. You still have to help place and manage those containers yourself. You still have to define resource usage and limits. So Fargate lets you just focus on that application. So no infrastructure, manage everything at the container level, launch really quickly, scale really easily. And I think the best way to describe this, right, is when someone asks you for a sandwich, they aren't asking you to put them in charge of a global sandwich logistics chain. They just want the sandwich. So they don't want to know how to cut tomatoes or how to make cheese or where turkey comes from. They just want to eat the sandwich. And to me, I think Fargate is really that sandwich, right? It just kind of works. You just pass in the container definition and the task definition, and that's it. So this is a semi-decent looking flowchart, and I made it myself, which is why it's not prettier. So if you want to run a managed container on AWS, these are your options. So first step, you choose your orchestration tool. So that's ECS or EKS. Next, you choose your launch type. So with ECS right now, you have two choices. You have EC2 mode and Fargate mode. For EKS, you can run it in EC2 mode. Coming sometime soon, Fargate mode for EKS. So What this comes down to is the level of control that you're looking for. So EC2 mode, manage everything down to your cluster hosts. In Fargate mode, only focus on the containers themselves. So the easiest way, I think, to think about Fargate is in comparison to ECS and EC2 mode. So this is what it looks like. Here's where you make that choice between Fargate and EC2. How do the pieces of ECS map back to things that you're already familiar with? So ECS, an instance, is a standard EC2 box. Once you register it to a cluster, that's where your tasks run. A service manages and places those tasks for you. A task is that container wrapper around a process that's running on your instance. So with ECS, you're responsible for managing all three of those, so the instances, the services, and the tasks. That means that you're responsible for configuring all of them. You can do that either through the ECS optimized AMI or your own, or with user data. You can configure everything through the ECS, the API, which you can either access directly or you can access it through the console. With compute for ECS, you choose your own instance type. That can be through a launch configuration, supports things like GPUs, spot instances, RIs, everything like that. So there's some similarities and some differences with Fargate. So you use the same task definition schema. You use the same ECS APIs to launch your Fargate containers. Easy migration, so you can run Fargate and EC2 launch types in the same cluster, so a hybrid cluster. And a lot of the building blocks of things like VPC and IAM and CloudWatch are the same between ECS and Fargate. So with Fargate, only 2 checkboxes instead of 3. So instead of being responsible for all 3 pieces, you're only responsible for the services and the tasks. So you no longer manage the instances. So the instances are not configured by you. So you can only configure at the container and task level. Same deal, though, as ECS. Configure everything through the APIs. Either access it directly or through the console. Tasks are through task definitions. Containers are through container definitions. So the way that compute works in Fargate is a little different, too. So it's basically a sliding scale of percentages between CPU and memory. So the first combination might be a quarter of a virtual CPU with either 512 megs of memory or 16 gigabytes. There's about 50-ish combinations of memory to CPU. Which brings us, I think, to the next question, which is, how do I know what to choose? And I think it depends a lot on what you're doing. And it comes down to how much control you're looking for. So if you can configure with just a task definition, and you're OK with some of the implications of Fargate, things like AWS VPC, which is a different networking mode, try Fargate. If you really need to customize, or if you need to run things like daemon processes or agents, or customize with EC2 user data, or you need to use RIs or spot instances, best to stick with EC2 mode for now. So that brings us to EKS. So Amazon Elastic Container Service for Kubernetes, which is quite a mouthful to say. So I'm going to call it EKS from now on. So to tell another little bit of a story, I think. So this is a number from the CNCF. It said that 57-ish% of Kubernetes workloads were running on AWS. And the thing that we were getting from most of our customers, right, which was run Kubernetes for me. We really like the technology. We really like the community behind it. We like the tools that we're using. We like the end results. But we don't necessarily want to run all of those pieces ourselves. And they wanted what came along with kind of managed AWS services. So how can I get things like AWS integrations? And how do I use my load balancer a little bit more easily? How do I use IAM policies? How do I use my VPC? And they wanted to keep it open source, just like we do. So using EKS, same upstream open source Kubernetes as you can use anywhere else, just get a little bit of help on the management front. So kind of a combination between the same Kubernetes that you can run yourself, plus a little bit of the Amazonian goodness. So how do I integrate with things that are already in AWS, like VPC and IAM and CloudWatch and CloudTrail, but still keep it the same open source Kubernetes experience where you can use all of your tools and open source projects and workflows and things like that. So that brought us to EKS. So just came out of preview into general availability a couple weeks ago. I think it was June 5th. We announced it on Twitch. This is what it ends up looking like. So manage Kubernetes control plane. And I'm going to dig into the architecture for a couple minutes, and then I'm going to let Roberto take over and talk about what they've been working on. So manage Kubernetes control plane helps you out with high availability, which I think has always been a little bit of a tricky angle for EKS, for Kubernetes. you can opt in to automated version upgrades. So if you want to jump from one version to another, you can get a little bit of help with that. Plus integration with other AWS services, so things like CloudTrail and IAM and VPC and Private Link and other things like that. As of a couple of months ago, we're also Kubernetes certified. So we're committed to remaining a part of the community, which I think is a lot of what makes Kubernetes so popular and so valuable. Is you have this really incredibly rich and vibrant open source community that's working on tooling and projects around it and demos and workshops and blogs. The Kubernetes community is really incredible. So we're committed to being a part of that community, and I'll talk about that in detail a little bit later. But we are Kubernetes certified. So digging into the architecture for just a couple of minutes. So this is what it ends up looking like. So this is what a highly available Kubernetes architecture might look like. You have 3 different masters. You have highly available etcd, and you have different worker nodes, and those are all located in different availability zones. So pretty standard, highly available, multi-master, highly available etcd, and highly available workers. So what this ends up looking like on EKS is that the masters are managed by us, and the workers are managed by you and your customer account. So bring any instance types you want for your workers, configure them however you'd like. We'll run a master for you in every availability zone in which you run a worker. Here's a different view of what that ends up looking like. So your workers connect to a managed control plane endpoint. So that's the mycluster.eks.amazonaws.com. And then you can use kubectl or kubectl or kubectl or however everyone's pronouncing that. I'm going to be equal opportunity and just use all of them. And that means I'm always right. So you can use kubectl or any other tool that you're already using. So I think part of what's cool for me about EKS is that it lets you keep working with the tools and the projects that you are already working with. So check in and talk to this endpoint however you'd like. You run the workers yourself, and they connect to that managed control plane endpoint. This is what cross-account ends up looking like. So you can see the dividing line between the green, I think, is a little faint. I should have made the line bigger. So that green is the customer VPC. Orange is the EKS VPC. You can see that the network load balancer is talking across both of them. Worker through the network load balancer, and they connect via ENI. So ENI is an elastic networking interface. So we attach that, and you can do everything through that. So that's how you end up connecting between what's running in your account and the masters that we're running for you. Here's a really exciting one. The red X is really a lot. So here's another view of what it ends up looking like with the masters running in the EKS VPC, communicating via ENI to the workers in the customer VPC. And you can see that they can still communicate through that ENI to workers in other availability zones, even if the master is lost in that availability zone. So as for master access and visibility, so things like logging and monitoring, you can do those with things like CloudTrail or CloudWatch. So the same way that you would for pretty much any other AWS service. So access logs and things like that, you get access to the master that we're running on your behalf through tooling. So AWS loves the Kubernetes community. So a couple different projects that we're involved in that I want to talk about. So you have the CNI plugin. So I didn't go in depth on networking today because we have Roberto coming up after this, and I'd rather him share his story instead. But we've been working on the CNI plugin. That's for pod networking in Kubernetes. That uses those ENIs that I just talked about in AWS. We've also been working with Heptio on the AWS Authenticator. That lets you use IAM credentials to work with resources in your Kubernetes cluster. We've been working on virtual kubelet. We're members of SIG groups and cloud provider working groups. Another cool example is the ingress controller for ALB that we've been working on with CoreOS and Red Hat and Ticketmaster. So really committed to making sure that not only are we part of the community, but that anything that we work on that's for EKS, we want to offer it back upstream to the community at large as well. So staying in these SIG groups, staying in these working groups, and then making sure that the things that we work on to enable Kubernetes to work better with AWS, that we're contributing back upstream as well. And ultimately, we want AWS to be the best place for you to run your containers, no matter how you want to run them. So I'm gonna step off now, and I'd like everyone to please put their hands together for Roberto Migli from the Thales Group to talk about their journey to Kubernetes.
So, hi everyone. I'm really happy to see all of you here. I'm Roberto Migli. I'm a TPM from Thales Service, and I'm going to talk to you about a success case of one of our customers, and more specifically about his road to Kubernetes. So about Thales. Thales is a group with a worldwide presence. We are present in over 56 countries, over 65,000 employees. And we work in many different fields, including defense and space and aerospace. My division is Thales Critical Information System and Cybersecurity. And we work into solution of software engineering, consulting of IT and cyber solutions, and IT operations. So this is one of the largest cargo ships in the planet. It's funny because you saw something very similar before from Avia. In this case, I'm not using this image to talk about Docker. It's maybe one and the first time that we're going to do this. We talk about this ship because when you think about those cargo ships operating in a port, you think about usually the physical flow of goods that move within the from the ship to the port, right? But what about all the data behind it? Imagine all the operation needed to do all the import, export, declarations, and so on. So that's where our customer comes in. The company is called MG, and they have a solution called the CA5. Cargo intelligence system, which provides a central system to manage all the data related to cargo and transport within a port community. So it allows all the players and stakeholders of the community to manipulate this data in a very effective way, and ultimately accelerating basically all the flow, the physical flow of the cargoes. So CA5 is a redevelopment of an old application called AP+. The customer wanted to iterate over the experience they had with the previous application. And what they were looking for, they were looking for something that was focused on the business solution and not on the infrastructure behind it. So really focus on what they need to deliver to their customer. They wanted also to have a fast time to market, so deliver it as fast as possible to their clients. And also, most importantly, they want to be everywhere in the planet. NG doesn't operate only in France. They operate worldwide. So they want to be able to deploy their solution close to their customers. And of course, high availability and scalability is central for their system. And all this trying to keep the cost down. So Thales is the company that provided the development of the solution, the architecture, the engineering, and also the operation of it. So we operate the solution 24/7. So the architecture, this is a very high-level feature of the architecture. We don't want to get too much into details, but what I would like to show you here is that we have one part of the application that runs within a VPC, in which basically we know the instances, we manage the instances. At the core, we manage a Kubernetes cluster, you can see on the top part. And on the lower part, we use like Aurora database, Elasticache, Elasticsearch, and other services to support the business applications. And of course, we deploy also some EC2 instances for the support operation part. So we have Grafana, Prometheus, and some other custom applications. And next to it, you can see on this part, we use a lot of AWS services, such as SQS, SNS, AWS Config, CloudTrail. You use really a lot of them, and it really looks like building with Lego blocks. And honestly, it's a lot of fun because you complement your architecture with a lot of services that really provide a lot of value, and most of the time, actually, they simplify your life. And next to it, we use our custom solution to provide supervision and operation called Isio. So why the architecture is like this? So what does this architecture, what does the architecture provide us? So first of all, one important point is that the whole architecture that you saw is actually managed as a code. We use Terraform for that, and we manage over 2,000 objects, cloud objects within Terraform. Kubernetes is the central part of the system because it runs all the system, all the business applications within. And we use Helm to deploy. If you don't know Helm, basically you can imagine it as a package manager of solutions to deploy application within a Kubernetes cluster. The infrastructure is elastic, so we react to the load, basically depending on what is the load of the system in terms of messages coming in from the external infrastructures. And also we do multi-region backups. So as Abby showed before, sometimes you have to think about the worst case scenario. So we wanted to have all the data also available in the backup region, which is Ireland. All the data, the central application runs in Paris, but we can redeploy through Terraform the whole infrastructure in Ireland in a few minutes. Also, security and operation, of course, is a central part of an enterprise application. So we focused a lot on security. We use HTTPS everywhere. We do continuous auditing through AWS config that monitors basically the changes within your infrastructure. And we use CloudTrail to audit all the access to the infrastructure itself. And again, we really try to keep the cost down. We use a lot of auto-scaling for both the business application and the software factory. We use Lambdas that also provide to a really cost reduction. And we have reserved instances. That is also a major advantage. Basically, when we know that we are going to run a certain workload for a while, well, we commit and we buy the instances in advance. And finally, we also provide integrated monitoring. So we collect both information coming from CloudWatch and from the custom metrics, the business application, to our hypervisor solution. So I think if you are here, maybe you're interested to know why you want to go to Kubernetes and the road that it takes to get there. So the project started in 2016, okay? And I tried to make this slide so that it shows basically time on the horizontal axis, and you have the number of containers you want to manage. As Abby showed before, there is a strict relationship between the two because you have orchestration layers, and then you have the number of containers you have to manage with it. So the journey always starts with Docker. So if you try to do Docker, and basically you say, OK, nice, I have my application packaged in Docker. I do Docker run, fine, nice. Yeah, but then what? You have now 15 containers, 20, 25 to connect together. Starts to become complicated because you're going to start to connect all your containers within all the cluster, with the machines of your cluster together manually. And so that doesn't scale very well. So our next iteration was to provide service discovery. So we give the system a brain, basically. It's Consul, which is a distributed key value store. And through Consul and other services that we developed our application to provide a reverse proxy, we were able to basically have a more elastic configuration. So you don't need to hardwire the configuration about the connection between each container. Instead, you have some middleware that allows you to connect dynamically the services. But at the end of the day, you're still doing your previous Docker run and all the commands by hand on each machine. So again, you cannot scale well and scale up to handle more containers in your infrastructure. And so this point doesn't want to be critic at all. We tried Nomad and Swarm, which are two orchestrators, absolutely valid ones. Also consider the time, like we tested both Swarm when it came out in the Swarm mode for Docker, which made it easier to use Swarm. And Nomad, it's also a simple orchestrator made by HashiCorp. This is the same company that makes Consul, by the way. And they provide a lot of features. Finally, you can control your cluster. You have a central point to deploy your application, and actually you stop talking about application, talk more about services. But still, there were some features missing, most notably the fact that you cannot isolate your workload within the same cluster. So let's say I cannot run dev infrastructure and UAT infrastructure within the same cluster. And also, we didn't find a way to protect the access to the API to deploy. So the operators were able to deploy whatever they wanted within the cluster. So today we use Kubernetes. What does Kubernetes provide to us that the solutions that I just showed before didn't provide? So I'm not going to repeat what Abby already presented. But Kubernetes clearly allows you to run containers at scale. That you run in tens of containers, hundreds or thousands. It's always possible within the same infrastructure. Just need more nodes, of course. It's really has a wide ecosystem around it, and most notably is supported by the Linux Foundation. It's part of the Linux Foundation, so I guess we can expect the Kubernetes to be around for a while. And especially also, it's really battle tested. Now it's used by many companies around the world in production and not for testing or just to play around. So what features provide Kubernetes? There is a conference about Kubernetes itself, KubeCon. So the point is not to show all the features of Kubernetes. It will take really too long time. We're going to focus on some of them. So first of all, we have namespaces that allow us to isolate workloads within the same cluster. So you can deploy basically, let's say, UAT and dev within the same cluster that is supported by the same machines while having isolation between them. You do have resource limits that make it easy basically to limit what you want to give in terms of power, computing power to each of your containers. You can expose easily all your services through ingress. Basically, you can expose your services to the rest of the world via this notion called ingress. And then you have an integrated horizontal autoscaler. So basically, you can scale pods horizontally really easy. It's really a matter of one change, one click, and you can do that. Also, you can deploy more complex application through stateful sets. You can deploy such things such as a database, a master replicated database, or Console itself, Zookeeper, Kafka, really many complex applications. Also, just in the slide, you can see on the right part the black thing. Well, one other nice feature that is not listed here is actually everything is code, again. So it fits well with the architecture of infrastructure as code. Security is the first class citizen for Kubernetes. You have role-based access control. You can basically say which person can do what on your cluster. Let's say, as I mentioned before, you have namespaces. You want to limit a person to operate only within that namespace. Well, you can do that. You want to limit what resources he can access within that namespace. You can do that too. You want to limit where to deploy. You can do that too. So really, role-based access control is a very nice feature that allows you to operate complex Kubernetes clusters. Also, you have secrets management. You can declare secrets that are going to be stored in a safe way within the HD infrastructure that Abby also showed in a slide before. And also, you have container network interface implementations that allow you to isolate logically the network interface within a pod. So for instance, you can say, well, this pod is totally isolated from the rest of the world. No one can access it. It can only send data out, but no data can come in. Again, there is many more features, and it's absolutely out of the scope of the presentation. Also, if you try to deploy Kubernetes, you might know that it's not so easy. It's easy to do Minikube. You have your laptop, deploy, like you download Minikube and run, that's fine. But running a scale, it's a bit more complicated. You have this HD part, you have many components that need to be deployed in the right way. Also, you want to have this the deployment to communicate with your infrastructure to provide the reliability and availability that you look for in production scale systems. So just before to get to how we deploy concretely Kubernetes, I would like to take a step back, talk about Terraform. I hope most of you know about it. If you don't, well, check it out. It's absolutely great. It allows you to declare as a code infrastructure. So remember this live node architecture with all the components? Well, we declare all of it through Terraform. Dependency, sequencing of the application, because when you deploy the infrastructure, you want to sequence out, like you cannot deploy an EC2 instance if you don't have the subnet to run it inside. This is all the problem with Terraform, and Terraform manages it for you. And also one important thing is makes your infrastructure, you can redeploy your infrastructure as many times as you want. Maybe for disaster recovery scenarios, or maybe to test out like some changes within a totally new infrastructure in another region if you want. So COPS is the actual component that we use to generate the Kubernetes cluster. COPS stands for Kubernetes Operations. And this is an open source tool that generates really production-grade Kubernetes for cloud deployments. COPS can deploy itself the cluster for you, or it can generate Terraform files for you that you can use. And we're going to see just how we're going to use it just in the next slide. And also, it takes a lot of heavy lifting for the bootstrapping of the cluster. And that, again, it's complicated if you want to do it by hand. So how the two Terraform and kops work together? You can start from the top left part, and basically at input, on one side, you have the template file that you use to configure your Kubernetes cluster. Let's say you want to run a multi-master solution that deployed in multiple availability zones, and you want this kind of instances, EC2 instances, maybe M5, C5, whatever you need, and so on. Also, it provides you a way to configure what you want to run inside these nodes. Maybe you want to start some other services for support. And then you give this to the kops engine, which generates two things. On one side, it generates Kubernetes config files on the top part, you can see. And then on the other side, it generates a Terraform file. So if you take this file, you make it a module. And then you combine it with all the other modules that you might have. So again, if you think back about the slide of the architecture, like you have maybe Aurora database or I don't know, any other part of the infrastructure that you want to provide, while Terraform modules allow you to combine all of them together. And just 1 second to talk about the fact that you can see in the slide, we don't use only Terraform. We use another component called TerraGrant. TerraGrant is a wrapper of Terraform that allows you to manipulate in a better way multiple modules of Kubernetes, of Terraform. And so with Terraform and TerraGrant, you can just call the API then, well, actually, Terraform does it for you. Calls the AWS API to actually generate finally your infrastructure, including, of course, the Kubernetes part and all the other components that you wanted to declare with the other modules. So that's all. Unfortunately, kops provides you with a cluster that is empty, and it's up to you what to do with it. And as Abby showed also with the EKS, you have other things that you want to have. For instance, you might want to have a centralized logging solution. So you want to ship all the logs from the pods to a centralized logging solution, CloudWatch, Elasticsearch cluster. Then you want to have a service mesh probably. So we use Linkerd in our case. Istio is another great product. Of course, you want also to have metrics about performance. So use something like Prometheus. Today is quite a standard, I would say. Security, so you can deploy, for instance, on the ingress, as I mentioned before, you can deploy a web application firewall in front. Helm needs to be provided also within the cluster. If you use a Tiller, it's called the agent, if you want to use Helm. And then all the roles required for the operations of your cluster. So for my part, that's everything. But if you want to see all this in action, we have a small demo in our stand, and that is stand B17. So if you want to meet me later there, you're welcome. Thank you very much.
That was awesome, wasn't it? So I think one of the coolest things about hearing customer stories like that is that you can see through Roberto's whole presentation how they tried something, they tested it out, they could see that it worked, or they could see that they wanted slightly different, they could tweak back and forth. And I think it's really incredible to see from a company all the way through, here's how we got to the place that we are now. So here's how we do kind of all of those beyond 101 things. Because I think we do a lot of talks, right, where it says, so like what I did in the beginning. So here's what EKS is, or here's what Fargate is. And I think what's even cooler than that is, how are people actually using this in production? And then how did people get to the point where they're able to use this in production? And production's not just setting up a cluster and saying, this sounds great, let's call it a day. It's things like logging and monitoring and automated deployments. It's how do we do things like service discovery? How do we handle things like fault tolerance and high availability? And I think it's really incredibly valuable to learn these, not only from customers like Roberto from Thales, but from all of your peers. So as always in my sessions, I've left a couple minutes at the end for questions, so we're going to get there in just a second. We'll not do questions up here, but Roberto has kindly agreed to join me at the front of the room if you want to ask some questions of Roberto and I afterwards. So stay tuned if you have a question, or I believe the Thales booth is B17. I don't know how to get there because I'm very confused in this expo hall, but I think you can find it. And if I want to leave you with anything else, I think, is that Werner mentioned this morning about joining a user group and being part of the community. And I want to really reinforce that, because there's a ton of user groups in France, and if there's not one near you, then start your own. But I think If you can't always hear from a customer at an event like this or at a meetup, I think the best place to learn things like these are from your peers. So if you're having a problem when you're working on something, or if you're like, I'm not really sure how to do service discovery, there's an incredibly rich ecosystem out there of people that are working on problems that are just the same as you. So learn from your peers, join a user group, join a meetup, write a blog, tweet me about it. I think I got 2 DMs from people sitting here while I was back there. Join a Slack channel, talk to your coworkers, talk to your peers, because from learning other people's stories is how we end up growing and how we end up getting better. And I think that what's been so powerful about things like Kubernetes is that the community is so involved, that everyone's working on it. They're looking at pull requests. They're submitting pull requests. They're writing blogs. So participating in the community, I think, is what makes us all so successful. So I'm going to stop talking now. And we will be back here in like 1 minute to answer questions. So that's all for housekeeping. We have a couple of sessions up after this. I believe it's another small break, and then there'll be a session after this, or hang out at the expo. But I hope you enjoy the rest of your time at the AWS Summit. And thank you again for joining me and Roberto and listening to us talk today.